Assalamu alaikum everyone, welcome to the video. As discussed before, we left in this slide. It was for solution by elimination. So today we will start by directly diving into the algorithms. In the previous video, we actually just went for some general representation and some theoretical remarks, but from today, it is going directly to algorithms that actually solve the system of linear equations. So let's get into it. There are lots of possible options over here. Like we can go for basic Gauss elimination method, we can go for Gauss elimination with partial pivoting, Gauss-Jordan elimination. There are triangular factorization methods like Doolittle algorithm and Zolewski's factorization, but to be honest, we will not be going through all of them. We will go through basic Gauss elimination method. The second one, Gauss elimination with partial pivoting. Over here we see the word partial pivoting. It's actually a technique. So you can say this is an algorithm. Is actually the basic Gauss elimination method with an additional technique added to it. That's called partial pivoting. Next up we have the Gauss-Jordan elimination method. So for this specific course or during this video series, we will not be showing anything about the triangular factorization method or any other methods. We will remain at basic Gauss, the addition of partial pivoting, and Gauss-Jordan elimination method. So solution by elimination, when we're doing that, we will still have to go back to the fact of representing our equation using a matrix. Over here we see the matrix which we studied already earlier, that if we are given any equation having n number of variables, and if there are m equations, say, then we can write a matrix over here in the right side to represent the set of equations as a whole. It contains all the values that are required to represent the equation as it is. However, as we can see, the variables, there are way too many variables over there, still n dimension and m equations. So for our case, to simplify it overall, we will actually narrow it down. We will narrow it down to say 3 by 3, that is 3 dimensions and thus 3 variables. So then we can represent it using a smaller matrix, just as the one shown over here. So say it once again, this is actually a general representation which is quite large. Okay, so we are going to slim it down to this one over here, and this one is actually represented using this matrix. This is actually to just help us do the calculation overall. Okay, so before I dive into a detail, once again let me remind you all that numerical methods is all about the method, not about the solution over here, because the solution will be done by the computer. We will need to use the technique to actually find the solution. So once again, what matters is the solution. What matters is the what doesn't matter is the solution. What matters is the process. So please be careful while using the process, because in this math or this type of topic, you actually have worked with it earlier and you may go for any topic, but no, it's not allowed. You have to remain in the topic that is being studied over here. So let's move on forward. From that matrix we can write this one. Okay, so let's go to the previous one. I'm actually trying to say that this matrix over here is actually copied over here. Okay, it's actually copied over here. So this is the matrix, if you watch carefully. Now what I really want to do over here is okay, first of all, partial pivoting is not being considered over here. It's actually without, or actually I will not be actually discussing partial pivoting over here. I will be discussing it a little later. Right now, just forget there exists something called partial pivoting. It's just a small part which I will add later on in this part. So let's get with the matrix. So if this is a matrix, okay, this is an overall matrix. My first step is trying to want making this 0 and this one is also 0. I want to make A21 vanish and A31 vanish, and in the process whatever happens to the other ones, that's just natural. We don't know why it happens or so. So what can we do over here is to make A21 become 0. Okay, so we know about row operations, right? We can say about row operations. What's a row operation? We if we study it carefully, something like this, r1 prime equals to, right, something like this. Okay, now let's go for a little more understanding part. Okay, so if we go over here, we can see that let's write the equations one again. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, and over here we have the matrix B1, B2, and B3. This is the total matrix. Okay, so just as I say, I want to make him 0 and him 0. Now what to do is we can take help from the row operation mechanism. Okay, so what's the row operation mechanism is that suppose that we know that we can write r2 prime so equals to r2 minus r1, something like this, right? We can write this, and what will it do is it will actually remain that a11, a12, a13 will remain unchanged, but in the next line what will happen, as 2 is before r1, it will actually do something like this: a21 minus a11, a22 minus a12, a13 minus a23, something like this. So this is actually row operation. And if I had something like r3 prime equals to 2 into r3, suppose I'm just trying to teach you all, this is not elimination, suppose, okay, suppose something like this, then it will actually be something like 2a31, 2a32, 2a33. Okay, so these are called actually the operations, and this is not my concern at all. And to be honest, what I really want to do over here right now, what my target is, as I said earlier, I have to make this one and this one become 0. That's what Gauss elimination is about. So how to make this happen? Okay, to make this happen, Gauss elimination also has a very fixed set of rule. So follow that rule and it will obviously become 0. So what is that? Is that you have to use r2 and minus r1 to get it. Then we have an a11, we actually have to remove a21 by minusing a11. Okay, so it's not possible. Okay, let me write it again: a21 minus a11, a21 minus a, sorry about that, actually made a mistake over here. Okay, so starting it off again, let's do it. Okay, um, as the row 1 remains unchanged, let's write it down. Okay, so row 1 remains unchanged. So next up is r2 minus r1, so it will be a2 A21 minus A11, A22 minus A12, A23 minus A13, and this one will be B2 minus B1. Now you see that we can see that if I divide A21, or if I remove A21 by A11, I cannot guarantee it's a 0, but there is a way. What if I actually multiply this part with A21 by A11? See what I'm doing? If I do this, I mean, if I just simply do it like this, it's actually applicable. Then it will become something like this. And over here, I can see that A11 will demolish this one, and this one will become minus. So I'll have a 0 over here. Okay. I get sorry. I get a 0 over here. Done. So similarly for R3 prime, I can do the same stuff. It will become R3 minus. Now look at the pattern over here. A11 was this value, okay, and A21 is the value that I want to remove. So I'm going to do the same stuff over here again. I'm going to write A31 divided by A11 R1, and this will obviously result this one in becoming 0 again, and this will be some other values that we can calculate. But as I said, my first and foremost task was to make this to 0. Sorry, my task was to make this to 0. Okay, this one and this one, I actually managed that. They are 0 right now. Okay, so here we have it. Our target is complete over here. So let's get back to the slides. So how is that happening again? So what we are doing is turning this one into 0. So over here the slide actually does the same thing. It goes to a step-by-step process. You can see over here it does this kind of operation, and it will convert it to a 0. Now in specifically Gauss elimination, after the first step is done, I consider that the row 1 operation is complete, and I will not be touching this one again. Next I have to use this and make this one 0. Okay, the triangular pattern, that is, make the lower diagonal of the matrix 0. That's the target it has. So what it does next, it works with R3, and this time it actually uses R2, what you can say as a pivot. Okay, so it uses R2 to reduce R3, and then it will get something like this. If you can see that this lower triangle actually is gone, it's 0 right now. Okay, so this whole part that is shown right now in the slide, it has actually a name, a single name. It's called forward propagation. Okay, this one is called forward propagation. And what happens next? What happens next is that if you look at this matrix carefully, okay, if I say that my variables were x1, x2, and x3, okay, what we can say that right now this matrix actually presents a11 x1 plus a12 x2 plus a13 x3 equals to b1. Over here we have a 0, so it doesn't matter. What matters is a22 prime x2 plus a23 prime x3 equals to b2 prime. And once again, as there are two zeros, sorry about that, this one, a33 prime x3 equals to b3. Now from this set of equations, I can already say that x3 will equal to b3 double prime divided by a3 double prime. So I'll get the value of x3. Now put the value of x3 over here. a23 prime and a22 prime are known, b2 prime are known. I'll get the value of x2, and if I put the values of them over here, I'll get the values of x1. And this Second part which I said is actually called the backward substitution, and thus doing this we actually get the Gauss elimination method answer. Okay, so you can pause, you can wait, you can try. We have some practice questions upcoming as well, so you can look at them for more clarification. We'll try discussing them during classes, so I hope you get it. So now here's a practice question over here. It's about Gauss elimination with partial pivoting. I'm just gonna go through the topic of partial pivoting over here, so you guys get an idea. We have an example ready, which we'll try doing during class time to actually figure out why we are doing it. So let me just give you a quick look. Okay, suppose in our first part of equation you get an a11, a12, a13. Okay, this one, and after the operation you get a 0 0 over here. By chance you get a 0 over here as well. Okay, and you get something like a32 prime, a33 prime over here. Okay, you got a 1 2, sorry, 2 3 prime, no problems. B2 prime, B3 prime. Suppose you got something like this. Now what will happen in the next step? You will actually suffer, because in R2 prime, where you will be going for R2 minus A3 A32 prime divide by A22 prime of, sorry about that, R2, you will see that this is a division by 0. So what to do about this? So this is where partial pivoting comes into action. What partial pivoting says, that before applying these row operations, we will look at the column that is we are talking about. For example, in this case we are going to work with the second row, so we're going to look at the second column, and the first row work is done, so we will actually skip the first row, and from the remaining rows what we will do is find the maximum absolute value, and with the maximum absolute value we will swap the values. So I just went through a very quick detail of what will be happening, but for more details we will actually discuss it during the class with examples. Next up is Gauss-Jordan elimination. Nothing much to worry about, considering if you already understand Gauss elimination. Gauss-Jordan is about a few more steps but more simple. So what I'm going to do over here is, if you look at carefully, so this is a whole matrix, and if I do this operation, this is, I convert R11 into A divided by this, it will actually become, it will look something like this, right? The first value becomes 1 as I divide by A11, and then these are the values that remain. So it's quite straightforward. The fun actually begins after that. Now that this one is becoming 1, okay, if you remember carefully, in Gauss elimination we had to multiply and divide, but now it's already 1. So if I can multiply it with a to 1 and make a minus, it will actually just go disappear, something like this. Okay, I can skip the video, you can look at it for a time and consider it. So what we did in Gauss elimination, we didn't have this step. We directly written a21 divided by a11 and a31 divided by a11, and we didn't do any operation in row 1. But over here we actually did an operation in row 1 first, then we applied it to R2 and R3. Benefits, I'll discuss it later. So pause the video, see if you can understand the calculation done over here. So what happens next after this step is, okay, this bird actually has a name. It's called normalization. This one is called normalization. What it does is normalizes. So like this one becomes 1, this is called the normalization. So next what we'll do is we're gonna normalize the row 2, and it will look something like this. Now after this, the major difference between Gauss elimination and Gauss-Jordan is that in Gauss elimination we discussed that once you have completed the operation with row 1, we will not go back to the row 1, but in Gauss-Jordan we will work in row 1. We will only skip the row that has been normalized, because we will be using it to negate the values. So we will actually skip that and all the other rows will be affected. So we will get something like this. Now we will normalize row 3 and we'll get something like this. So after this whole operation is complete, after the completion of all these operations, if we look at this matrix over here, we can say that it actually represents something like x1 plus 0 plus 0 equals to b1 triple prime, 0 plus x2 plus 0 equals to b2 triple prime, 0 plus 0 plus x3 equals to b3 triple prime. And from this part I think I'll just can say that x1 equals to b1 triple prime, x2 equals to b2 triple prime, and x3 equals to b3 triple prime. So actually I got the answer. I do not in Gauss-Jordan elimination I do not need to go for a backward substitution. This step is enough, so there's no specific forward propagation and backward substitution. I just got the answer. So that's pretty much it. And as I discussed, the partial pivoting part will actually be discussed in broad during class. Please remind me when we are in the class. So yeah, that's about it for solution by elimination. I think it has been long enough, so we'll end the video over here for today's class. I hope that you all understood, and for quiz we do have the class time. So yeah, keep trying. Thank you very much. Assalamu alaikum.